Welcome to this explainer. Look, if you've been working in the AI space for any amount of time, you already know the massive headache of gluing together fragmented Python scripts, managing brittle API calls, and dealing with those absolute integration nightmares just to get an LLM to do something remotely useful. Well, today, we're moving way beyond basic chat prompts. We are going to engineer a reliable, tool-wielding, deeply secure AI agent natively in Java. And to do this, we'll use the context of building a master sommelier to map out exactly how SpringAI elegantly puts all these complex architectural pieces together into a fully production-ready application.
So let's just dive right into the architectural blueprint. Today we're looking at 5 key areas: memory and knowledge, tools and structure, the MCP connection, security and moderation, and finally, metrics and observability.
Starting off with Section 1, memory and knowledge, which is really the foundation of the whole system.
To get things off the ground, we have to move past a simple hello world and graduate to what you might call hello LLM. Because without state, your agent essentially has amnesia, right? A sommelier that literally can't remember what flavor profiles you said you hated 10 seconds ago isn't going to be very useful. But SpringAI solves this natively through its conversation history, which is mapped directly to message window chat memory. By just passing a conversation ID, the system seamlessly injects the last 5 interactions back into the prompt. So without you having to write any kind of complex caching logic yourself, your agent suddenly has short-term memory and can actually carry a natural flowing conversation about your shifting wine preferences.
But, memory is only half the battle. Our sommelier also needs deep, specialized knowledge. Imagine your sommelier trying to recommend a Bordeaux without knowing the specific, nuanced flavor profiles of the 2015 vintage. To fix this, we connect to a vector database, which in the Spring ecosystem is really cleanly mapped to the vector store interface. It acts as our gateway to retrieving that domain-specific data. For our specific blueprint, we're plugging into a ChromaDB collection packed with thousands of highly detailed wine reviews, basically dumping massive amounts of specialized expertise directly into the agent's brain.
Now, to actually use that vector data, we implement a retrieval pattern. But instead of writing all that manual, highly error-prone retriever logic, Spring handles this so gracefully via the question-answer advisor. When a user asks for, say, aromatic wines, the question-answer advisor automatically intercepts the prompt, queries the vector store, and then seamlessly injects the relevant context before the LLM even sees it. It ensures the model returns highly specific floral and savory wine suggestions grounded entirely in our custom dataset. This effectively eliminates the risk of the model hallucinating a vintage that simply doesn't exist.
All right, moving to Section 2, tools and structure. Let's give this agent some actual capabilities.
So to achieve real-world impact beyond just its static training data, we have to grant the LLM new, dynamic skills through tool calling. This is really what turns the AI from a passive encyclopedia into an active participant. And in SpringAI, this is strictly and elegantly mapped using the .tools method. You literally just pass in your custom tool class using code like .tools, passing in new your tool class with this .vector store, and boom, instantly, your agent has the capability to actively query your database or call an external API the exact moment it realizes it needs missing information to fulfill the user's request.
But here's a critical reality for enterprise developers who are dealing with back-end systems. Unpredictable text blobs are an absolute nightmare for legacy integration. Because we're building an agentic system that must interweave with other enterprise software, we absolutely have to enforce a clean, predictable, structured output. And Spring achieves this beautifully just by appending .entity along with our specific Java class, like winedetails.class. This guarantees strict type safety in Java, coercing the LLM's chaotic output into perfectly structured JSON that matches our back-end models every single time.
Section 3, the connectivity, powered by the Model Context Protocol, or MCP. With tools and structure firmly in place, we face a major integration challenge for our growing architecture. Think about it. How do we connect our applications and models effortlessly to new skills and resources? If we suddenly have 5 different language models and 10 different enterprise APIs to support our sommelier, writing bespoke glue code for every single combination creates this unmaintainable web of technical debt. We desperately need a way to standardize this connection so we aren't constantly rewriting integrations from scratch. Well, the answer to that technical debt is the Model Context Protocol, or MCP. Think of it as a universal plug-and-play layer for AI. In our architecture, this is natively mapped in Spring via the tool callback provider. Instead of direct, low-level data access scattered everywhere in your codebase, MCP creates a completely decoupled, protocol-driven service layer.
It standardizes the handshake between the LLM and the local environment, letting our applications seamlessly connect to any new tool or model without rewriting the underlying logic at all. And the implementation details really matter here. Pairing this MCP integration with Spring Web Flux provides an incredibly smooth reactive experience. When your sommelier is generating these long, complex flavor profiles, having asynchronous, non-blocking thread generation is absolutely crucial. To quote the developer testing this in the source material, it's smooth as a well-aged wine, resulting in silky streaming and zero messy stack traces. It is for sure the modern, highly performant way to handle asynchronous AI tool calling. Which brings us to Section 4, Security, Guardrails, and Content Moderation. Because an enterprise blueprint is basically useless without safety.
An unpredictable AI is a massive liability. SpringAI provides two distinct approaches to handle this. First up, we establish firm boundaries using security and guardrails, which are mapped directly to the Safeguard Advisor. This is absolutely critical for filtering out restricted topics, like strictly limiting our agent so it can only discuss wine and absolutely nothing else. Second, for a more proactive defense, we implement content moderation using moderation prompt. This actually utilizes a secondary, specialized LLM to actively scan user inputs and agent outputs for harmful content before the core application even gets a chance to process it.
To prove this dual-layered security actually works, our developer threw a wild curveball at the endpoint. It was a highly inappropriate prompt asking the sommelier to use a wine delivery to essentially blackmail someone. By using the free Omni-Moderation latest model as our fast, low-latency scaffolding layer, this prompt was instantly intercepted before the primary LLM even saw it. The system blocked the request entirely and returned a strict 403 error, so our sommelier stays strictly professional.
Finally, Section 5, the Operations, focusing on observability and core metrics.
We've built a highly capable agent, sure, but we aren't done until we can monitor exactly how it's performing in production. Check out this number, 228. This represents the token usage from a single query mapped in our logs. Now, in agentic architectures, language models might loop multiple times through different tools just to answer a single question. Every prompt, every tool call, every RAG retrieval step, it all costs tokens. And if you aren't aggressively watching your token burn rate per step, I promise you, your cloud bill will completely spiral out of control before you even notice.
But luckily, Spring exposes these generative AI metrics natively right out of the box using its built-in actuator endpoints. Actuator perfectly handles system health and those high-level token counts. However, for true agent-native apps, you really need deeper visibility. Pairing SpringAI with a platform like LangFuse gives you that observability. LangFuse allows you to see visual, node-based traces of your agent's exact thought process, track exactly which database the LLM decided to query, manage prompt versioning, and even run evaluations on your AI's underlying logic.
And there you have it. We've journeyed all the way from a simple, stateless hello LLM to a secure, highly observable, tool-wielding master sommelier. We've seen exactly how SpringAI maps these complex architectural components, from utilizing message window chat memory for continuous context, bridging vector store for deep knowledge, deploying tool callback provider for standardized MCP integration, to enforcing those strict boundaries with the Safeguard Advisor. Now that you hold the complete blueprint to SpringAI's agentic architecture, the only real question left is, what kind of enterprise agent will you build next?